Hello, everybody. So today we're going to be talking about waste disposal. So it turns out you can get in some issues with something as simple as waste disposal, as actually happened here last year. So this picture is taken down in the PCHEM lab, where it turns out that somebody decided to add a little bit of inorganic waste, including some oxidizing agents, to a organic waste. Oops. So uh, turned out that this bottle was releasing a little bit of heat, maybe degassing a little bit, and then was capped accidentally. At which point the pressure blew up, and sometime over the weekend we ended up with this. So again, this is one of the important illustrations of why so many of your instructors care so much that you put the right waste in the right bottle, because otherwise, well, this happens. So let's talk a little bit more about waste disposal. So again, one of the things you should always be keeping in mind, no matter what step of a chemical procedure you're at, is what are you going to do with the waste? And so one of the biggest things you should ask is what's going to be the easiest way to manage this waste? And it turns out the easiest way is almost always finding an alternative. So this is the whole field of green chemistry. If you have to choose in between a procedure that, say, generates a lot of waste versus something that generates a little, say maybe something that goes into 2 steps instead of 10 steps, a procedure that maybe needs a lot less solvent or produces things that are drain wastable, always go for the ones that produce the least amount of waste. This is the whole idea behind the field of green chemistry. In addition, always think about how much material you need. So if you only need a gram of product, don't use a synthesis that will produce about 10. So try and make sure that you're using the actual amount of material you need. In addition, whenever you end up finding yourself buying chemicals, make sure that you consider the full cost of buying. So even though it may be cheaper per gram to, say, buy on the kilogram level, this doesn't always mean you're going to be saving money, because one of the things you have to account for is the fact that we actually have to pay to dispose waste. We have certain ways that we have to pay to store chemicals as well, because turns out we can only keep so many chemicals around for so long. And if you're not going to use it, you probably shouldn't buy it. So again, even though it might seem like it's cheaper, think about how much you actually need. So one of the things that is worth noting is that it is actually, you are actually able to drain dispose some amounts of waste in limited amounts. So again, for example, I can dispose of bleach down the drain, but only if I have a little bit. I don't want to start disposing of 10 kilogram levels, as that might be a little bit problematic. Most of these materials tend to be water soluble, thus they can enter the cleaning system. And they tend to be very low hazard materials, or materials that essentially quickly become non-hazardous as they react with water. Some biologicals can go down the drain, say something like a simple agar, but make sure they are not infectious, nor can they become infectious. And oftentimes, even when you are disposing of your biologicals, you're generally going to want to go send them through through an autoclave or some other way to render them into non-living. And so there's certain subsets of chemicals that can typically be put down the drain as long as you keep your amounts pretty much below 100 grams a day. So again, this actually isn't that much waste, but it includes a lot of our common ions, things like aluminum, calcium, magnesium, potassium, and sodium. So a lot of these you're going to find in some commercial salts. Some you have to watch out a little bit more for. So things like protons, because again, I can send down protons down the drain, as in I can drain dispose acids, but you want to make sure that they aren't too concentrated, otherwise I may end up eating through my metal pipes. Similarly, you might want to watch out for things like ammonia, because while this is non-toxic and is actually essential for life, that can be the problem. And that ammonia is a classic pollutant in the sense that it can cause harmful algae blooms and interfere with some waste treatment plants. We also have some of our anions, and they include some of our common ions like bromine, chlorine, and iodine, which you're going to find in a lot of food products, as well as nitrates, which again, found in many food products, but suffer some of the same issues as ammonia, as it can be an environmental pollutant. We also have things like sulfuric and phosphoric acids, acid conjugates, but again, watch out that you're maintaining low concentrations. And even if you are keeping the total amount going down the drain pretty low, again, make sure to rinse with lots of water to try and dilute out the system. But again, one of the big things I want to emphasize is even though these ions are permissible, it's always in small amounts. One of the other things you have to watch out for is hazardous waste materials. Because when we can't send it down the drain, this means that we actually have to maintain the hazardous waste on site until it can be disposed of. And so we're going to have certain chemical storage protocols that need to be followed. And these typically fall under several governmental regulations. First of all, we have the Toxic Substances Control Act, which gives the EPA authority to control chemical production and usage. We also have the Resource Conservation and Recovery Act, the RCA, and this gives the EPA control over the generation, transport, treatment, storage, and disposal of hazardous waste. So this is essentially the idea of cradle to grave hazardous waste management. And again, one of the things you also have to watch out for is there may be a lot of other very specific federal and state regulations. State regulations can vary from state to state and even from county to county. So make sure you're aware of what any local regulations are for the use and storage of chemical waste. As well as there's many federal regulations which are oriented towards certain types of waste, whether it's something like biological samples or, Lord help you, if you start working with things like radioactives or heavy metals. So again, make sure that when you're using waste that you're aware of what special regulations there may be for that type of waste. One of the other important things to be aware of is, as we saw previously, make sure that if you aren't during disposing your waste, that everything is separated according to appropriate category. So some of the classic separations are going to be keeping your halogenated organics away from everything else, because as we saw before, halogenated organics will tend to interact a little bit too heavily with some plastics and often need to be waste disposed of in a very different way than non-halogenated organics. A lot of non-halogenated organics can be disposed of by incineration. That unfortunately leads to some toxic gases when we're dealing with halogen groups. And then we'll typically separate out our inorganic waste with our general heavy metal waste. And you'll often make use of a biohazard bag for toxic biological samples. But again, when in doubt of what to do with a particular waste or where to put it, ask. It never hurts to ask to see exactly where it goes, especially in case you encounter a possible reactivity issue. Because again, there's a lot of possible chemical reactivity out there, and while doing your research before you start a procedure is always recommended, you may miss something, so never be afraid to ask. So one of the other important things to keep in mind is, where do we collect waste? So waste is typically collected first at the lab level in hoods, and should be contained in a secondary containment. However, it's then collected typically at satellite collection points throughout the building, and then eventually all collected in a central storage facility from which it can be sent to an external treatment location. And when you go ahead and start collecting um, your waste, it's very important that all your waste bottles have a label. And the very minimum amount of information that a waste bottle must have is the date of collection started and the date of collection stopped, and the identity and amounts of all materials present. Because again, you need to know exactly what's in the bottle to know what type of waste treatment is allowable. For example, incineration and burial. Now, once you've filled a waste bottle, you have 3 days to get the waste to a satellite collection point and then quickly to the central facility. And once the bottle has been completed, so we've hit that date of collection stop, you've got 6 months to move the waste off site. If you take any longer than that, you're actually in violation of regulations. So again, make sure that all waste treatment and disposal uh, occurs on a timely schedule. So let's say I go ahead and I collect all of our waste in a central facility. How do I move it off site? So most small generators of chemical waste, and yes, Truman actually is a small generator, use what's called a lab pack. So this is essentially the idea of I take a 55-gallon drum and I more or less start putting in all of my all of my hazardous materials into the drum, and then I pack it full of some sort of absorbent material, typically vermiculite, which is essentially kind of clay that's highly absorbent in case any of the bottles crack. In addition, it also acts as a stabilizing agent to prevent any of the bottles moving around and breaking. And all of these bottles should be sealed and labeled and then sent off to a final disposal. Typically, this occurs either as incineration, specifically if you're talking about non-halogenated organic waste. But as soon as you're talking about halogens or heavy metals, that typically means a specialized landfill. One of the other important things that's worth noting is that when we do generate a lab pack, it's typically best procedures to separate them based on hazard type. So for example, I'm going to want to keep my oxidizing waste away from my organic waste in case something bad does happen. And again, this is what we use here at Truman. So this gives us the major idea of what sort of how we should store chemicals and how we dispose of the waste. Next time, we're going to go through essentially a quick rundown of best practices of lab behavior. Till then, take care.